Okay, Year 7, I'm going to move on with the next exercise or the next part of our work, which is the arc length and perimeter of sectors and composite figures. So it sounds really complicated, but it's not. And some of these shapes are going to look very imposing, but they're not. You just need to break it down. So the first thing we need to remember is that the circumference of a circle is pi times the diameter. And we learnt that in the last one. Where pi is a number and it's on your calculator, you can see it down here underneath the 3, but to access it, you've got to press Shift and that there, and you can see you get pi up there, and if you press equals, there it is as a number, 3.141592654. It goes on forever. It is irrational, which means it cannot be written as a fraction. So that's the circumference of any circle. And remember, the circumference is just the distance around the outside. So when we say the circumference, we're talking about all the way around there. But sometimes we don't get a whole circle. So this is where we need to develop an understanding of fractions and how to calculate that. So first of all, let's have a look. Now you should have had these in your notes. We call part of the circumference of a circle, for example, this bit here, that they have indicated with an L, and that's a cursive L, is called an arc. So somewhere in your notes, you might like to write what an arc is. It's probably easier to draw a picture. Now, to find how much of the circle that, or the circumference that arc represents, you need to know something. And you need to know that all the way round in a circle, if I go all the way round a circle, well, we measure that in degrees, and that is 360 degrees. So all the way around a circle. Now, if we don't go all the way around, if we only go part of it and we use an angle, and they've indicated this angle here with this Greek letter theta, well then we've gone that much. So imagine if theta was 30. Well, we'd have 30 degrees of a whole circle. And that's going to be important when we do fractions. So it's going to be easier if we just go straight to a question. So we'll go down here and we'll go straight to these ones. Now remember, we're doing questions 1, 2, 5, and 6. Now I'm not going to do all of them, but I'm going to do enough of them to get you going. Now, these first two, these are pretty easy because you can tell how much of a circle that is. And if you didn't, I'm going to show you how to work it out. So most of you will go, well, that's pretty easy. That's a quarter of a circle. And this, well, that's half a circle. But if you didn't know, you'd have to go, oh, that's the angle. And you'd have to remember that that's 90 degrees. So 90 degrees over 360. And you can just put that in your calculator. Just go 90. I'm in stat mode, so I better get rid of that. So I'll just clear that. And I'll get rid of my stat mode because it doesn't allow me to have fractions. And if I type 90 over 360, it gives me a quarter. The other thing you need to know, if you didn't know that that was a half, you go, well, how much is that? Well, that's a straight line. So that's 180 over 360. And if you put that in your calculator, you should get a half. So if we go back here and change that to 180, there you go, you get a half. But I'm pretty sure most of you would know that you've got a quarter and a half. So when we do question 2, I'm just going to get rid of this. When we get to question 2, we're going to be using our calculator. for the ones that we can't work out in our head. So 2a, well, we already know that's a half. Well, that's okay, that's a half a circle. 2b, it's the same as the one above, it's a quarter. 2c, well, they've given us 60 degrees. Well, to work out how much of that is a circle, we put it over 360. Now, if you are good with numbers in your head, you might be able to work that out. But if not, just go to your calculator. And what do we got? 60 over 360. And we get a sixth. D, well, this time it's 120 over 360. That's how much of a circle we've got. So we use our calculator again. We go back. Remember, the back arrow is really good. Saves you having to do a lot of work. And that's a third. Now the next one they don't tell us, but they give this little thing here, which means that that's 90. Well, some of you are already going, oh, I know that that's 3/4. And go for it. If you know that that's 3/4. But if that's 90, that means I've got 360 minus 90 left in there, which is 270. So for E, if you go straight to 3/4, good on you. But you've got 270 over 360. And you have to use a little bit of geometry there. And again, on my calculator, that better come out as 3/4. So I go back here, 270, 3/4. Now the last one. You see if you can do the last one before I do it. So pause the video. And it's 225 over 360. And you go back to your calculator and put that in. Five eighths. So that's all pretty easy. Now, we're going to go straight to question 5. Now, we're no longer finding the circumference because these are not whole circles. We are finding the perimeter. So I'm not going to do every one. I'll do A, C, and E. You see if you can do the rest. So here's 5A. Now, when you're finding the perimeter equals, first just get the straight bits. So there's that straight bit and that straight bit, and because they're parts of a circle, that's pretty easy. 4 plus 4. Yes, because those two bits are the same, because they're the radii of that circle. But now I've got to calculate part of a circle. Well, how much have I got? Well, if you remember from the questions we did before, you've got a quarter. I prefer to write 90 over 360 because I'm going to use it all the time. I'm going to use whatever the angle is over 360. It just saves me any trouble. I know that 90 over 360 is a quarter. So this is now for the curved bit. So I've got the two straight bits, but I've got to work out this curved bit. And it's 90 over 360 times pi times, now here's where you have to be careful, the diameter. Well, the diameter, it's not 4. If I had this whole circle here, the diameter would be 4 and 4. So the diameter, this is a tricky one, is 8. So that's the only tricky part, getting this bit. Once you've written it all out, you just put it in your calculator. So what have I got? 4 plus 4 plus 90 on 360. Now, the reason I'm going to write this is because I'm going to use my backwards button all the time. So 90 over 360, because most of these are going to be the same, times, now remember how to get pi, shift and the button underneath the 3, you get pi, then times, and remember the diameter is 8. Press equals. Now, because we have pi in there, we're always going to get a decimal. How many decimal places? So 14.28 3185. 3185, and it keeps going. Well, how many decimal places do they want us to go to? 1. Now remember, to round decimals, you draw a line there. You go, well, 14 point, is the number behind the line 5 or bigger? Yes. So we round up. Remember to put your units in. It's in centimetres. So there's the first one. Now, the next one. You're going to do exactly the same thing with the next one, except you're going to be using 10. So I'm not going to do it. I'm going to do C. So 5C. Well, the perimeter equals all the straight bits. Well, the straight bit is that bit there. So 20. Plus, and I'm going to always use the angle over 360. I know it's a half a circle. You can put a half in, but I'm just going to go, well, I know that that's 180 over 360 times pi times, now what's the diameter? Well, I'm lucky in this question, they've actually given it to me. The whole way round is there, so the diameter is 20. So I'll just put in this 20 here. So then I go to my calculator. I'm just going to use my backwards arrow. What have I got? 20 plus, I don't have 90 over 360, I have 180 over 360 times pi times 20. 51.4159. And it goes on. Remember, we are rounding to 1 decimal place, so I go there. That's going to be 51 point. Well, the number behind there is less than 5, so I'm going to leave that alone. What units is it in? Millimetres. Okay. Now I'm jumping down to E. And I'm going to do E and F. You have a go by yourself. So here I go again. You can pause the video now, try it yourself and see if you're right. I need the straight bits. Well, here's a straight bit, this bit, and this bit. And they're both the same. So that's 4.3 plus 4.3. Now, how much of a circle do I have? Well, I've got 60 out of 360 times pi times, now, be careful here, the diameter. Remember, the diameter is the whole way around, the whole way through. So imagine if we had the rest of the circle and that went all the way through. Oh, that'd be another 4.3. So 2 times 4.3, you can use your calculator, it's 8.6. So my diameter is 8.6. Then I just go to my calculator. I go back because I'm using the back button. It's just quicker. And what have I got? I've got 4.3 plus 4.3 plus, how much of a circle have I got? 60. I've got my pi. And what is the diameter? 8.6. And I get 13.1029. 13.1029. Dot, dot, dot. I'm rounding off to 1 decimal place. So that will be 13 point. Now, is the number behind the line 5 or more? No. Leave it alone. What units are we in? Meters. Now, I want you to have a go at F by yourself. I'm going to do it quickly now. I'm going to really fly this time, so you've got to try and keep up. You can pause the video if you need to. What is my perimeter? Well, I've got my two straight bits, so 3.5 plus 3.5 plus, how much of a circle have I got? 115, I think it is. Yep, 115 over 360 times pi times the diameter. What's the diameter? Well, if the radius is 3.5, 2 times 3.5 is 7. Bang, put it in my calculator. So I go back and I've got 3.5 plus 3.5. I don't have 60, I have 115 of 360, and my diameter is 7. And I get 14.02495. 14.02495, I think it was. Yep. I'm going to one decimal place. I go there, and then I go, 14 point. Now, is that number behind the line 5 or more? No, leave that there. And even though it's a 0, you must leave it as a 0, and we're in centimetres. So don't just ignore that 0, you've got to write 14.0. Okay, now question 6. Again, I'm not going to do all of these, they're not that hard. Remember, just do the straight bits and the circles. So here we go, 6a. Let's have a look at this. Okay, now remember, you need to know what these symbols mean. That means that those two sides are equal, and it means that that one there means that these ones are all equal. So what have I got? So let's get all my straight bits. So I've got a 3 and a 3 and a 4 and a 4. Okay, so my perimeter. And I like to write them all out. So I've got 4 plus 4, they're the two sides with the green double sign, and a 3 and a 3. Now, that dotted line, that's not part of it. That's inside. Perimeter is just the outside. Now, I've got something on 360 times pi times my diameter, because I've got this much of a circle. Well, how much is that? Well, they don't tell you, but they should. There's a little 90 degree in there. So it's 90, which is a quarter. You could write a quarter. Now, what's the diameter? This is a dangerous bit. So many people will write 3, but it's not. That's the radius. I need to double that. So I'm going to times it by 6. So this looks really complicated, but it's not. It's quite easy. You just get all your straight bits and then the curve bit. So again, calculator, I've got a lot to do here. So get rid of all those. What have I got? 4 plus 4 plus 3 plus 3 plus how much of a circle? 90 times pi times the radius is 6. Bang. 18.71. 18.71 ... What are we going to? One decimal place. I'll draw my line down here. Is that 5 or more behind? No, leave it alone. 18.7 meters. B. You have a go at B by yourself. B is very similar. All right, I'm not going to do it if you need any help with that, but it's almost exactly the same. I'm going straight to C. Now, if I look at C, what have I got here? Here are my straight bits. There's that straight bit there, that straight bit there, and that straight bit there. And then the curve bit is that bit there. All right, so I am going to draw a dotted line in there to show me the middle bit. So I've got half a circle and 3 straight bits. So my perimeter is 30. That's a straight bit on the left-hand side. Plus 12, plus 12, plus I have a half of a circle, but remember I'm using the angle, so I'm going to write 180 over 360 times pi times the diameter. Well, I'm lucky now because the diameter, this bit here, is the same as this. So the diameter is 30. And again, once I write that, that is the most important line. This, showing all your substitutions, is the most important line. The answer, yeah, it's important as well, but it's not as important as showing what you're doing. So here we go. What do we got? Go back, use my back button, and I'll just get rid of all those. What have I got? I've got 30 plus 12 plus 12 plus, how much of a circle? 180. You could write a half times pi times 30. 101.123. 101.123 dot dot dot. 1 decimal place. 101 point, is the number behind there 5 or more? No, leave it alone. What units are we in? Centimetres. Right. D is very similar. So I'm going to finish with E and F. You have a go at them on your own. Okay, perimeter. Remember, get all the straight bits. So where are my straight bits? There are only 2 straight bits. Here they are, there and there. So 10 plus 10. So 10 plus 10. Now, how much of a circle have I got? Well, this is this tricky one like we did up above. All the way around there, well, I know that that is 90 in there, and I've got 270, 360 minus 90. So I've got 270 degrees. Now, if you use 3/4, that's just as good. So plus 270 on 360 times pi times, what's the diameter? Be careful. It's not 10. That's the radius. You need to double it. So times 20. Bang. Back to my calculator. What have I got? I've got 10 plus 10. Oh, I undid it all. I'm going to have to do it again. That might be a good thing anyway. So 10 plus 10 plus, I need my fraction, so you can see how I do this again. 270 divided by 360 times pi. Remember how to get pi? Shift down here underneath the 3, and then times 20. 67.123. Dot, dot, dot. Rounding to 1 decimal place. 67 point, is that number behind 5 or more? No, leave it alone. What units are we in? Millimeters. And there we go. Now, you have a go at the last one before me. I'm going to do it here. 6F. So you can pause the video and go and have a crack. Okay. This looks tricky, but it's really quite easy. So what have I got? Let's have a look. First of all, my straight bits. Well, I've got this straight bit here and this straight bit here. They're both 10. Easy. Let's get them out of the way first. So F, my perimeter equals 10 plus 10. Now, how much of a circle have I got? Okay, well, down here, I've got half a circle, and up here, I've got another half of a circle. Well, hold on, a half and a half, that's just a whole circle. That's easy. I don't even need to do a fraction. I've got a whole circle because I've got a half and a half. I could put it all together and just have one whole circle. Oh, you mean F is the easiest question? F is indeed the easiest question. It's just 10 plus 10 plus pi times the diameter. Because it's not a fraction, it's a whole circle. It's a whole circle. Okay, a whole circle, and the diameter of this circle is 8. So it equals, and I go to my calculator, 10, I don't need that fraction anymore, 10 plus 10 plus pi times 8. And that is, what do we say, 45.132. 45.132 dot dot dot. We're going to one decimal place, so that is 45.1. What units are we in? Centimetres. All right. That should be enough for you to be able to get through those. Hopefully you've understood. Make sure you have a go yourself and keep working at it. Good luck.